when source moving with velocity u approaches a listener at rest and passes away. We want what is beat frequency. Now, when it approaches, then frequency is more. When moves away, frequency is less. So bit frequency will be N1 minus N2. That means this is N original frequency, V upon V minus U, N into V upon V plus U. So it will be N, V common, V plus U minus of V minus U root of V square minus U square. That is NV, V minus V will get cancelled, 2U upon V square minus U square. So 2NVU is upon V square minus U square is called beat frequency. If U is very, very less than V, this is, we know, it is 320, 330, 340. Not given anything, we'll take 340. If given, then definitely it is in that 300 range. And this is speed of the source. Maybe 5, 6, 7, which is very small. I can neglect U square. Then U square can be neglected. Therefore, beat frequency will become 2NVU upon V square. That is 2NU upon V if V is very small. So remember this, and wherever you see U is in 1 digit, this is in 3 digit squares, you can neglect. Copy. This is beat frequency when source is approaching and passes away. Completed?
Yes, sir.
Next is Twinkies apparatus. It is used to verify interference phenomenon of sound. It consists of 2 tubes outer tube has two opening, inner can be moved to and fro. Sound is started. Inner tube can be moved to and fro. The sound is divided into two parts. Now, if when this tube is pulled ahead by X, so both sides it will get pulled ahead by X. The diagram is there. This is the tube, and this is inner tube, which can be moved to and fro. Inside one can be moved to and fro. If X is distance by which inner tube is pulled out, then they can say find what is wavelength if waxing is heard or if vanning is heard. So at waxings, we know path difference equals to n lambda. So if it is pulled by X, then total path difference will become 2x from top and bottom. That will become n lambda. And for vanning, you have to write 2x equals to odd multiple of half the wavelength. So just write, if sometimes they ask this sum, then this is how we have to approach. Completed?
Yes, sir.
अभी अपना 3 चैप्टर हो गया एक्चुअली. Oscillation, sound wave, wave motion. Now I'm doing synopsis of stationary wave. Then I'm starting with MCQs of all these three together. I do understand you will forget many things, तो बीच बीच में भी समझा दूंगा. But ये chapter at least make perfect in 15 days. 15 days means today is Thursday. Coming Thursday will be 13. By 20th, this chapter should be perfect. Stationary waves. What are stationary waves? Actually speaking, पहले concept देख लो पहले. What is meaning of stationary wave? See, if somebody is running, I want to stop him. तो एक तो मैं उसको फोन कर सकता हूँ ना, you have to stop. If he is not carrying phone, then I can tell my other friend to run in opposite direction and catch him. So if both are running in opposite direction, ये टकराया, दोनों का अगर ताकत सेम है तो ये इधर नहीं जाएगा, ये इधर नहीं, जगह का जगह पे वाइब्रेट होगा. ऐसा वेव को स्टेशनरी वेव बोलते हैं. Like suppose you take one thread, pass within the two holes of coin of cold drinks, and you rotate it, pull from both sides. Can you see waves in between? Have you ever tried this? Like if this is round, here there are two holes, I pass string and rotate this, pull it from both sides. तो ऐसा wave दिखता है ना आपको ऐसा? Have you ever tried this?
Yes, sir.
Yes, sir.
Meaning देखो क्या है? All waves are harmonic. So whatever answer I get for one time period, same will be repeated in another time period. So I'm dividing time period in 4 parts. T0, T by 4, 3T by 4, T is T. First particle, second particle, third, fourth, fifth, sixth, 7 particles are there. Suppose total 1, 2, 3, 4, 5, 6, 7 particles. When one wave starts from here and other wave gets reflected from other end, when it meets each other, then this is 0, 0, no vibration. 2, up A, down A, no vibration. 3, no vibration. 4, no vibration. 6, no vibration. 7, no vibration. That means that T equals to 0. The waves cancel each other. No particles are vibrating. When T is T by 4, then this wave will slide up to 2 and leave this partial behind. Seventh, when comes here, this way it will propagate. Now if I take their superposition, then at 1, particle is maximum in downward direction. A, 2A downward. 0, 3A upward. 4, 0. 5 downward. 6, 0. 7 upward. So this will be that nature of wave. When time is T by 2, then that wave will come to third position here. That means crest will become trough. And while reflection 7, 0, here T by 4, it will again get inverted like this. Now if I superpose, all will be 0. All will be 0 at T by 2. At 3, T by 4, at 3T by 4, the wave will come at this position. And this will be propagating behind like this. 0, T by 4, T by 2, 3T by 4 will be propagating like this. Now if I see resultant, it will be A upward, 0, 3 downward, 0, upward, 0 and downward. So this way will be the wave. When T is one time period, so entire one cycle will be again repeated. That means wave will come here. We can see this repeating same format. And while reflection 7, 6, 3, it will come here. That means it will be in same format. Again, result will be 0, 0, 0, 0, 0. So if I try to see this all on one line, then nature of two waves having same amplitude, same time period, traveling in opposite direction, when they interfere, then at T equal to 0, at T equal to T by 2, at T equal to T, no particles are vibrating. But when T is T by 4, this is the nature of wave. And when T is 3T by 4, then this will be the nature. And particles here, they are vibrating like this. Such type of waves are called stationary wave. These points where particles are not vibrating, they are called nodes. And where they are vibrating with maximum amplitude are called as antinodes. That means Whenever stationary waves are formed, at some points particles do not vibrate. Those points are called as modes. And some point particle vibrates with maximum amplitude. Those points are called as anti-modes. Okay.
Yes.
So what are stationary waves, or when the stationary waves are formed? When two simple harmonic progressive waves traveling along same straight line but in opposite direction interfere, then resulting waves are called stationary waves. At some point particles do not vibrate, those are called as mode. At some point they vibrate with maximum amplitude, called as anti-mode. That means when two simple harmonic progressive wave of type y equals to a sine omega t plus or minus kx interferes, then resulting waves are called as stationary waves. Stationary waves are given by y equals to 2a cos 2 pi x upon lambda sine omega t. Okay. At some points, particles do not vibrate. Do not vibrate. These points are called as nodes. At some points, particles vibrate with maximum amplitude. These points are called as anti-node. Please copy these 3 points. Any doubt? Feel free to ask.
So what does SHPW stand for?
Simple harmonic progressive wave.
Okay, thank you. So can antinodes be positive and negative or only positive?
I didn't get what you're saying.
Can antinodes be like positive and negative or only positive?
No, it will be either plus 2a or minus 2a. So maximum will be on upward side as well as downward. It can be plus or minus 2.
Okay.
Return.
Yes, sir.
Distance between consecutive nodes or consecutive antinodes is lambda by 2. See, this was node, this was node. What is distance? Half wavelength, so lambda by 2. Similarly, node and this node. This is lambda by 4, lambda by 4. Total distance will become lambda by 4. So distance between consecutive node or consecutive antinode is lambda by 2. Distance between node and nearest antinode is lambda by 4. 6. All particles performs SHM with varying amplitude. 7. Particles in same segment are in same state of vibration and in adjacent segment they are in opposite state of vibrations. One more point we can write. Energy is not transferred in stationary wave. Energy is not transferred in stationary waves. Write these points.
Sir, can you read the eighth point?
Energy is not transferred in stationary wave.
Okay.
Completed?
Yes, sir.
What is velocity of transverse wave along stretched string?
Under root T by M.
Under root 2 by m. Velocity of transverse wave along stretched string is V equals to root of T upon small m. T means tension, small m is mass per unit length or linear density. Small m is mass per unit length, also called as linear density. If string vibrates with one loop, then what is loop length? One loop length is how much? Lambda by 2. Hello? One loop means lambda by 2.
Yes.
Frequency of vibrating string with P loops is given by n equal to P upon 2L root of T by n. Because if string vibrates with P loop, then P lambda by 2 is total length. So lambda is 2L by P. D equals to n lambda. D is root of T by m. N is to be calculated 2L by P. So n becomes P upon 2L root T by m. This is called frequency of vibrating string with P loop. Yes, copy. Written?
Yes, sir.
Fundamental frequency of vibrating string, comma, n equals to 1 upon 2n root of p by r. That is, n is inversely proportional to L, directly proportional to root 2, or inversely proportional to 1 upon root of L. String always vibrates with all harmonics. That is n, 2n, 3n dot dot dot. Second harmonic is first overtone. Third harmonic is called second overtone. Therefore, pth harmonic equals to p minus 1 overtone. Overtone means extra node as compared to basic mode. Like if it is vibrating with 2 nodes, this is basic. Then when extra node comes, it is called first overtone. 2 extra node comes, second overtone, and so on. Yes, clear? What is meaning of overtone? Overtones are actually frequencies other than fundamental. They are always present. Means you can't say first overtone, then next will be third. It has to be first, second, third. Harmonic first के बाद third हो सकता है, but not the overtones. They are always present. I have remembered in simple number of extra node as compared to fundamental mode. Yes, 2.
Done, sir.
Air column in closed pipe. Air column in a pipe roasted one. It can vibrate with minimum antinode and node, then it is called fundamental. One extra node comes, then first overtone. Two extra node comes, then second overtone. This is length L, length L, length L of the pipe. This distance is lambda 1 by 4. This will become lambda 2 by 4, lambda 2 by 2. So lambda 3 by 4, lambda 3 by 2, lambda. Just draw this diagram. In fundamental mode, vibrating length L is lambda 1 by 4. So lambda 1 is 4L, N1 is V by lambda 1, V by 4L. This is formula for fundamental frequency. This is fundamental frequency in closed pipe. Then second case we'll get L is lambda 1 by 4, lambda 2 by 4 plus lambda 2 by 2. That is 3 lambda 2 by 4. Lambda 2 is 4L by 3. And 2 is V upon 4L by 3. So 3V upon 4L, which is 3 times N1. This is third harmonic. Just copy with diagram to understand what is first harmonic, third harmonic.
सर सर ये पाइप बोथ एंड क्लोज्ड की एक एंड
Okay.
दिस पाइप इज क्लोज्ड both ends or single end.
If it is closed at both ends, there can't be vibration. So whenever it is told pipe closed pipe, that means one end.
Okay.
both end है ही नहीं है, both end closed हुआ तो vibration नहीं होगा.
Okay.
क्योंकि vibration के लिए आपको ऊपर ट्यूनिंग फोर्क रखना पड़ता है.
Yes.
Once you complete, tell, huh?
Done, sir.
Okay. So third harmonic we got 3 times N1. Can I clear the diagram and everything?
Yes, sir.
Now in third case, if you look the diagram, in third case, L is lambda 3 by 4, lambda 3 by 2 plus lambda 3 by 2. So LCM is 4. It will be lambda 3, 2 lambda 3 plus 2 lambda 3. That is 5 lambda 3 by 4. So lambda 3 is 4L by 5. Frequency is V upon lambda 3. That will become V upon 4L by 5. 5V upon 4L. 5 times N1. This is fifth harmonic or second overtone. So thus, in general, air column in closed pipe vibrates with only odd harmonics. That is N, 3N, 5N, dot, dot, dot. Here, this is nth harmonic, but first overtone. So, pth overtone is equals to 2p plus 1 harmonic. Overtone 1, 2 into 1, 2 plus 1, 3 harmonic. Overtone 2, 2 into 2 plus 1, fifth harmonic. Now copy. Written?
Yes, sir.
Where column in open 5. Where column in open 5. Empty node. Where columns are free to vibrate at open end, hence empty nodes are formed. So this is one node basic, two node, 1, 2, 3 nodes. In this case, vibrating length L is lambda 1 by 4. So lambda 1 equals lambda 1 by 2. Because empty node distance is lambda by 2. So lambda 1 is 2L. Frequency is V upon 2L. This is fundamental frequency or first harmonic. This time vibrating length in second case, it will be lambda 2 by 4, lambda 2 by 2, lambda 2 by 4. Lambda 2 by 4 plus lambda 2 by 2 plus lambda 2 by 2. That will become 4, 2, 3, 4. 4 lambda 2 by 4. That means lambda 2 is L. Frequency is V upon lambda 2. It will become V upon L. Multiply by 2 and divide by 2. So N2 equals to 2 times fundamental frequency. Just draw the diagram and copy this case 1, case 2. Then
Yes, sir.
case 3, will be vibrating length L, lambda 3 by 4, lambda 3 by 2 plus lambda 3 by 4. So this will become LCM 4, lambda 3 plus 2 lambda 3 plus lambda 3. Open at both ends. So 1, 2, 1, 2, 3. Lambda by 4, lambda by 2, lambda by 2, and lambda by 4. Plus lambda 3 by 4. So it will be 2 lambda 3 plus lambda. So total it will become 6 lambda 3 by 4. Therefore lambda 3 is 12 by 3. Frequency N3 is V by lambda 3, which is V upon 12 by 3. Therefore it is 3V upon 12. Therefore it is 3 times N1. This is third harmonic or second overtone. Thus, air column in open pipe vibrates with all harmonics. That is N to N dot dot dot. Now,
Done, sir.
When open pipe is suddenly closed or closed pipe is suddenly open, then frequency becomes half. This you have to remember. When open pipe you close, then frequency will become half. Second, if we want number of harmonics, or overtones present in, if we want number of harmonic or overtone present in given frequency, then find ratio of given frequency upon fundamental. So with this you can get 1, 2, 3, 4, 5. They are nothing but harmonic. From harmonic we can count overtones. So, in sonometer wire, vibrating length in resonance is found by paper rider method. Right. When open pipe is suddenly closed, frequency becomes half. Then if we want to find harmonic or overtone present in given frequency, find the ratio of given frequency with fundamental.
Done, sir.
Maltese experiment. In Maltese experiment, one prong of tuning fork is tied to string and made to pass over pulley and carries pan at free end. It is used to find unknown frequency of tuning fork. Is used to find unknown frequency of tuning fork by adjusting fork in two positions. First, longitudinal position or parallel position. Second, transverse or perpendicular position. Just write up till this, then we'll see meaning of transverse and longitudinal position. Yes, done. This also written.
Yes, sir.
Yes, sir.
Yes, sir.
Now, longitudinal or parallel position means what? Here the prongs of tuning fork are made to vibrate parallel to the length of string. By adjusting weight in the pan, tension is created and this string vibrates. In this position, frequency of tuning fork is twice the frequency of string. Tuning fork, if it makes one vibration, the string, two vibrations, string makes one. So n is double the frequency of string. How I am explaining at the end. N means P upon 2L root of T by M. So N is P upon L root of T by M. Using above formula, frequency of tuning fork can be determined. Then squaring both sides, we get n square equal to p square upon L T by M. So Tp square is n square, L square squaring both sides, we get Tp square equals to n square L square M. This is constant. Okay, just copy this one. Draw diagram also properly. T1 P1 square is T2 P2 square.
Done, sir.
Transverse or perpendicular position. Here prongs of tuning fork are made to vibrate perpendicular to the length of string. In this case, frequency of tuning fork is same as vibrating string. So it is P upon 2L root of T by N. Squaring both sides, we get both sides we get n square equals to p square upon 4n square t by a. So tp square is 4n square n square m. That is tp square is constant. So t1 p1 square can be written as t2 p2 square. Right. Rahul, we wait after the lecture.
Yes, sir.
Done, sir.
For same setup, number of loops in transverse position is twice in longitudinal position. See, in transverse position, frequency is same. So P1 upon 12 equals to root of P by M. The rest, everything is same except the position. In longitudinal position, N is 2N. So it is 2 times P2 upon 12 root of P by N. So from 1 and 2, we get P1 upon 12 root of T by M is P2 upon L root of T by M. Root T by M L, root T by M cancel. So number of loop in longitude transverse is twice that in longitude. Complete. Completed now?
Yes, sir.
So today we'll stop here. Tomorrow same time we'll start with MCQs after resonance tube experiment.